Well, chapter 3 and chapter 4, scatter plots, correlation, and linear regression. All right, this chapter is about how to state or how we're going to model or try to model a relationship between two variables. All right. A simple way to establish a relationship between two variables, x and y, is by using a linear relationship. Linear relationship. What is that? Remember, a linear relationship, to be more precise, a linear equation or linear function is one that can be written in the form y equal to mx plus b, where m is the slope and b is the y-intercept. We're going to be using a similar equation here. So if you remember the properties for those kind of equations or functions, is going to be useful in this part of the course. First, we are going to use a little different notation for that here. If a relationship between y and x exists, we will try to model it with a model in the form y hat equal to a plus bx, where y hat is predicted value of y, I'm sorry, for a given value of x. This one, the b is representing the slope of this linear equation, and this one, the a, is going to be the y-intercept. But well, with this we are going to see several things. First, how can we know whether we can use a linear model to describe or try to describe the relationship between these two variables? Well, let's see one example. The example is going to be based on the book, on the exercises from a chip. This one. This exercise from the homework number 4 from a chip, or homework number 5, well, whatever. I did homework for this module. Yeah, I think I did homework number 4. It says, scientists examine data on a mean summer sea surface temperatures in degrees Celsius and mean coral growth in millimeters per year over a several year period at locations in the Red Sea. And then here you have several values. We have noted we have some, the first one, temperature, is going to be, we're going to label that as the X values, and growth is going to be the Y values. Here it says, use your calculator to find the mean and the standard deviation of both sea surface temperature, the correlation between X and Y, and all of that. Well, we're going to be doing all of that. It says here that you will have to do it with your calculator. So we are assuming that you will have to do this by hand. Well, I'm not going to do all the computations by hand. I'm going to explain how to do the computations. Is that okay? Indicate how to do that, and then you can verify that, or well, you can use Minitab. But first, we need to create this scatter plot. This scatter plot for this, we're going to construct this by using Minitab. First, you have to go to Minitab. We don't have a file for this exercise. You see, no link for any file in this exercise. So you will have to enter the numbers. You see, like I did it here. You will have to enter the numbers. It's not very complicated because we have only 7 numbers for each. So 1, 2, 3, 4, 5, 6, 7. This temperature is going to be the X, and let me put it here. Temperature is the X, and growth is the Y. There you have temperature and growth. So you will have to enter the values for temperatures and growth here. Next, we're going to create a scatter plot. What is a scatter plot? It's another graphical method that we're going to be using in this course. It's mainly used when we are using linear regression or correlation. It's related to that. How do we do it? Go to graph in the menu, then scatter plot. You see this one is the second option, scatter plot. Click there, only simple, nothing special here. And then you will have to indicate what the Y variable is and what the X variable is. If you see, that's what I labeled this. Y variable is growth, double click, and X variable is temperature. Double click. There you have. And then OK. And there you have. This is the scatter plot for this this problem. What is this for? It's very simple. You have to, every point represents a pair. For example, the first pair, for the X it has 29.79, so it should be 29.79 here in the graph, and the corresponding Y value is 2.82. So you see 29.80 approximately corresponds to 2.82 in this diagram called the scatter plot. And you do the same for all the other values. When you are using a scatter plot, you don't have to join the points by using any curve or a smooth curve or a line, something like that. No, you don't have to do that. Only plot the points. That's all what you have to do. Now, what is this for? Do we see, or do you think we have a good linear relationship here? By the way, remember, when we have, if we have a linear relationship here, if we can describe the relationship between X and Y by means of a linear equation or linear function, that means what? That the graph is a straight line. So the first thing you will have to do with the scatter plot is that you can have an idea about whether we have a good linear relationship or not. Do you think that all the points they can fall inside a straight line? If so, then you can say, do you say oh yes, or you want to say no? No problem. Is that okay? In my opinion, I think yes, we can assume that these points fall inside or along a given straight line. So I want to write down that. Notice I have here, this is the same example that I'm using from the homework on a chip. So number one is scatter plot. By looking at the scatter plot of this data, a straight line seems to be a reasonable model. There you have. Of course, in some of you think, no, I don't think that they follow a straight line. That's okay. You can say that, no problem. We're going to see next one way to measure this. How can we measure how good, if any, how good the linear relationship is? All right, so to do that, we're going to use something called the correlation coefficient. Correlation coefficient. The correlation coefficient is defined in the next way. R equal to 1 over n minus 1 times the sum of Cxi times Cyi. And what is each of these concepts? Well, first, let me write it here. Let's see that example. Yeah, it's right. Here, first, be careful. N is the number of pairs. XY. Yeah, do not think that the N is going to be the total number of values. No, it's going to be the number of pairs X and Y, or in this case, temperature growth. So we have 1, 2, 3, 4, 5, 6, 7. In this case, it's going to be the number of columns. So N is going to be equal to 7 only in this case. But in general, that is N. The other concept, this one, Cxi is equal to each X value minus the mean divided by the standard deviation. And Cyi is the same. Y value minus the mean divided by the standard deviation. Of Y. So X bar, mean of X values. Y bar, mean of Y values. Sx, standard deviation. Do you remember that? We're going to be using that a lot in this course. Standard deviation of X values. And obviously xy is standard deviation of y values. There you have. So you will have to compute here for each value, for each x value, for example, you will have to subtract this value minus the mean and divide this by the corresponding standard deviation. So let's see first what is the mean and standard deviation. In our example, x bar is equal to what? How do you compute this? Well, you will have to sum all the values and divide them by 7 for the x values to compute the x bar. But you can do it in Minitab, and the same for the y. That's why I put the numbers here. So go to stat, basic statistics, display descriptive statistics, and do it for the variables temperature and for the variable growth. Here we're going to need only the mean, standard deviation. We don't need the quartiles here. So you can uncheck those boxes. Neither the maximum or the minimum. We need the mean and the standard deviation for each. There you have. Okay. And there you have. Temperature, the mean is 30.291 and the standard deviation 0.455. So let me do it here. X is 30.291. Y bar is equal to 0.564. The standard deviation of x 0.455, and the one for y 0.32. I want to round it up to 3 digits. 0.234. There you have. So once we have this, again, I'm not going to do all these steps. Actually, there is an exercise on Achieve where you will have to do, well, you're supposed to do it to complete these steps. But here I'm going to explain only how to compute this. For example, I'm going to compute R. In our example, we have this. N is equal to what? Is equal to 7 in our example. There you have. So what is going to be R? R is going to be 1 over n minus 1. I'm following this formula. 1 over n minus 1. 7 minus 1 times, what is the meaning for this notation? This is the sigma notation. If you have taken the course Calculus 2, you learn about this notation. It's only one way to indicate the sum. So we have to sum over all the i's from 1, in this case from 1 up to 7, because we have 7 values. So in this case, 1 over n minus 1 is going to be the first x value. What is the first x value? It's 29.79. 29.79 minus x bar. X bar is 30.291. And that divided by the standard. Oh, I think I have to put this below so I can have more space. I'm going to do it here. R is equal to the first x value, 29.79, 1 over 7 minus 1 times 29.79 minus x bar 30.291 divided by the standard deviation of x, 0.455, times, do the same for the first x value. What is the first x value? The first x value is 2.82. So we have to do 2.82 minus the mean, but the mean of y. The mean of y is 2.564 divided by the standard deviation of y, 0.234, plus, now do it with the second value. Second value of x, 29.94, minus the mean, 30.29 divided by 0.455, times the second y value. What is the second y value? 2.75 minus the mean of y, 2.564 divided by 0.234, and so on. Is that okay? And so on until you cover all the x and y values. The last x value is 30.84, 30.84 divided by minus the mean, 30.29 divided by 0.455, times the last y value, 2.23 minus the mean of y, 2.564 divided by 0.234. You see? Like that. These 3 dots means that it continues in this way until we are done with all the values. That okay? Again, you can do this by hand. If you do it by hand, you're going to verify that the value is the value for R that you get is going to be this one. R should be equal to 0.916, and I'm going to explain some things about R later. But by now, it's going to be R 0.916. That okay? If you do it by hand, if you do all of these computations by hand, yeah? But you can use Minitab to verify this, of course. Once you have the values in Minitab, go to the menu, go to Stat, Basic Statistics, and look for the one correlation. You see that? Again, Stat, Basic Statistics, correlation. And then only put the 2 variables, x and y. Put the 2 variables in this box. And then OK. You're going to have again the scatter plot, but you're going to have the correlation coefficient. Negative point, oh yeah, it is negative 0.916. I missed the negative sign. I'm sorry for that. Well, that's why I verified this. Negative 0.916. That okay? So this is how you compute the correlation coefficient. You can do it by hand. I know it's going to be tedious, but on the from the homework on a sheet, you're going to have some exercises where you will have to complete the steps like if you were computing this by hand. Anyway, I recommend to use, if you have the opportunity, to use Minitab to verify your answer. Now, let's talk about this R. How to interpret this R. I'm going to mention some properties for R. Properties of R. First, number one. Well, anyway, they don't follow necessarily an order, but number one is always. R is going to be always between -1 and 1. So this means if you have a value, if you got an R greater than 1 or less than -1, something must be wrong. Number two, if the R is positive, then this means there is an increasing relationship between X and Y. This means that as X goes forward, then Y goes upward. If R is negative, then as X goes forward, then Y goes downward. What happens if R is equal to 0? Might indicate no linear relationship or a constant relationship. A horizontal line. I mean, this would indicate that the Y values, they don't change no matter the values for X. The Y values don't change. If we have a constant relationship, that happens. If the R is equal to 0, the correlation coefficient is equal to 0, it might indicate that. All right. Another important thing, 1, 2, 3, 4. Five, the closer that the absolute value bar is to 1, the better the linear relationship. So in other words, the closer that is the R to either -1 or 1, that means the absolute value close, very close to 1, the better the linear relationship. So in our example, we got r equal to -0.916, all right? So this means that it's very close to -1. Well, that's my opinion, right? What is exactly very close? But you will have to use your criterion. Very close to -1, in my opinion. So I would say that the linear relationship, or to describe the relationship between these two variables, x and y, by using a linear relationship is okay, or is very good here. In our example, since r is -0.916, the linear relationship is very good. All right, now, what is next? Once you have verified, you say, oh, I have seen the scatter plot. I have verified my observation with the correlation coefficient. Next, we have to set up the model. But how to do that? Getting the model y equal to a plus bx. Here, how to compute a and b. B is going to be computed by using the formula, the correlation coefficient times the standard deviation of y divided by the standard deviation of x. And once you have B, you can compute the A. A is going to be equal to the y bar minus B times x bar. Do not be careful. Do not confuse the y bar with the y hat. This is you have to read this as y hat. Y hat. And this one is the mean, it's the y bar. Yeah, well, I call it y bar. So let's compute this. In our example, what is B? B is equal to the correlation coefficient, -0.916 times xy. What is xy? 0.234. 0.234 divided by Sx, 0.455. And we are supposed to get -0.471. Please verify that with your calculator. Then, once you have once you have B, A is equal to y bar. Y bar is 2.564. 2.564 minus the B you just got, -0.471 times x bar. What is x bar? X bar in our example is 30.291. 30.291. So A, please verify that A is supposed to be 16.831. There you have. Once you have this, then only set up the linear regression model. Then the linear regression model, set up the model by now. Is y hat. How do we set this up? It's simple. Only write down the equation with the indicated value, with the obtained value for A and for B. A 16.831 minus 0.471x. That okay? And now you can use this to predict values. For example, predict y hat for a value of x. What are the values for x that we have? Notice any value inside the range of these values is going to be okay. For example, we can choose 30 exactly. 30 for a temperature of 30 of x equal to 30. So what do we do? At x equal to 30, y hat is equal to 16.831 minus 0.471 times 30. See that? And we have 0.471 times 30. And I got 2.701. So how to interpret this? One way is this. We have temperature and growth. The growth was measuring what? Millimeters. So we can say for a temperature of 30 degrees Celsius, the growth is 2.701 millimeters. You see? But I'm sorry, I forgot one key word or two keywords here. Is in the average, (2.701 millimeters). These two words are essential when you're using a linear regression model. This is the linear regression model actually. Linear regression linear regression model. It's this one. linear regression model. So once you have the linear regression model and you want to use it to predict y values in terms of the x, you can do it, but that prediction is going to be only an average. What is the average growth for a temperature equal to 30 degrees? 2.701 millimeters in the average. That's why we are not using exactly y, because y corresponds to the variable, to this one. We can say these are the exact values from the sample for this y, but we are not predicting exactly the values. We are predicting values in the average. In the average. And that is very important and essential to understand this. All right. So, oh, by the way, you can verify these computations by using the Minitab. How to know what the value, we can verify our model. Go to stat, regression, you see this, stat, regression, fit regression model, responses. In this case, the responses are the y variable. Y. Continuous. Notice we can have here categorical predictors, but I think we're not using this in this course. So only just continuous. We're assuming here that the two variables are numerical. The two variables in this kind of model, in this linear regression model, should be numerical, numbers. So that's why we use continuous, x, and then OK. And you're going to be given these results. So you see regression equation 16.83 minus 0.4708 temperature. You see? Is the same we got? Yeah, it is. 16.831 minus 0.471. So we can say that our answer is correct. Well, here is rounded up to 3 digits, but it's essentially the same. Is that okay? All of this stuff we are not going to talk about in detail about this one. But what our only concern here is to verify the model. And it is correct. So let's continue. All right, more example from the book. This is one example from the exercises on a chip. It says algal blooms can have negative effects on an ecosystem by dominating its phytoplankton communities. Goniostum semen is a nuisance alga infesting many parts of northern Europe. Could the overall biomass of G semen be controlled by grazing zooplankton species? Our research team examined the relationship between the net growth rate of G, that semen, the number of Daphnia magna grazers introduced in test tubes. Net growth rate was computed by comparing the initial and final abundance of G semen in the experiment, with a negative value indicative of a decrease in abundance. The table contains the findings. And there you have, right? Yeah, I know. Most of the times we're not going to be familiar. Well, at least not me, right? Familiar with the nature of the data, but the point is that we know we need numbers, and we need to know what we're going to do with the numbers. So here it says to access the complete data set, click. We have to download it from the assignment. So let's do it. I'm going to assignments. This is the one that I just did. You see? This is the one that I just did. Now, this is the one. In my randomization of the questions, is my question number 3 out of 10. Is the algal blooms, right? So I need to download this. So I'm going to download the worksheet from Excel. I know, I'm sorry, the options here, they show up in Spanish. I'm going to choose here the option guardar enlace como. In English, remember this is save as. Save as in English. I'm going to download this. I'm going to put it here in this folder. And I think it's going to have a problem because last time I was having some troubles when I tried to open this directly, right? So what did I do? Maybe the problem is because I'm working on a MacBook Pro or a Mac computer. So what you can do is only open the file in Excel and then again guardar como in English should be save as, and save it only with the extension .xlsx, the first one, this one, .xlsx. With that should be enough. I close this one and then I go to Minitab and I open the file. File open, worksheet, local file, and you see it gives me the option to open the file with the extension .xlsx. And I open it, and there you have. See, 1, 2, 3, 4, 5 is the same as we have here. Yeah, the same. And here we have to find only the correlation coefficient. So the correlation coefficient is only, again, go to basic statistics, and look for the one of correlation. It's this one. Correlation. You can erase this, enter the two variables. You don't have to enter here in order, no problem, right? And then, well, I mean, for the correlation only. And then just click OK. And you're going to have the scatter plot, and the correlation is -0.928. -0.928. So I'm going to put this here. -0.928. There you have. So we're done with this example. This one is a college freshman. Again, it's another one in your homework chip. Let's look for it. College freshman involved in a dating relationship agreed to participate in a 9-month-long study. Every 2 weeks, participants answered a detailed questionnaire about the relationship and their emotional well-being. Over the course of the study, 26 of the participants experienced a breakup. The average distress of these 26 participants at the time of breakup, 0 weeks, and over the following 10 weeks was assessed from their questionnaire answers. The table showed the findings in a scientific publication. And if you see in this problem, we have again data from Excel. So I'm going to download this as well. Guardar enlace como, remember for you is save as in English. I'm going to save this in this folder. I go to the folder, it's this one, open it, guardar como, again, save as, and use extension .xls. Oh, I think it was saved like that, right? Yeah. Why? I don't know. It was already saved with the extension .xlsx. Well, perfect. So I don't need to save it again. I close this and then I open this directly from Minitab. File, open, worksheet, local file. Yeah, I don't know why, but fortunately it happened. There you have 02610. It's the same we have here. 0 to 610, yeah. All right, so what are the question we have here? Use the software of your choice to make a scatter plot from the given data. We're using Minitab. Choose the scatter plot that best matches the one you created. So I think we have to create the scatter plot. We already know how to do it. We go to graph, look for the scatter plot, simple, okay. What is the y variable here? Average distress. Distress is the y variable, and the y variable is time. Okay, and there you have the scatter plot. So you have to verify what is the one that matches with this one. I have it here in my notes. You see, it's the first one. It's the very first one. So please verify you see that in your homework. Should the correct explanatory variable? We said that the x variable was what? Time since breakup. So it has to be that one, yeah, so this one. Time since breakup. Should the correct description of the relationship between average distress and time since breakup? What is the correlation coefficient is? No, we don't have. Well, we can check the graph. Now there, I'm going to add color to the points so you can see them better. This is what? Obviously here, the correlation coefficient must be negative. Why? Because as the y values are increasing, the y values are going downward. You see that? The average stress is decreasing over and over. So in this case, the relationship is decreasing. So what is the one we have to choose? Is negative, linear, and very strong. Yeah, I know we haven't computed the correlation coefficient. If you want, you can compute it. It doesn't say here we have to do it, but yeah, I think we can model this situation with a linear model. I think it's very strong. It's negative. So I think the one is negative, linear, and very strong. I think it's the first one. Oh, and we have to compute the correlation coefficient, right? It's negative 0.99, yeah. So, well, you already have here the answer, but you have to compute it in Minitab. Just to verify, go to Minitab. Remember, go to Calc. I'm sorry, I was confused that. Basic statistics. Correlation. Stat, basic statistics, correlation. Correlation between time and distress. You don't have to follow an order here. And then okay. And the answer, scroll down to have negative 0.994. Yeah, this answer is from the book, it's negative 0.99. Yeah, it was rounded up to 2 digits. The correlation is very close to -1, which is very strong. Yeah, this is the option. Well, we're done with that example. One more example. This is another example from the book. I think the Department of, yeah, here you have. Department of Motor Vehicles warns of the effect of drinking alcohol on blood alcohol content. Abbreviated by BAC in percent of volume. One drink is defined as 12 ounces of beer or 4 ounces of table wine. Oh, that's okay, right? The impact of a single drink on a person's BAC, blood alcohol content, depends on sex and weight. For a 160-pound man, the blood alcohol content as a function of the number of drinks consumed in 1 hour can be expressed by the regression line. I'm going to write it here. So this one, we have the model here. This one is going to be your y hat, and number of drinks is going to be your x, so that we can have the model y hat equal to 0.03 times x. What happens to the a? What happened to the plus, the constant? We don't have that constant here. We can say it is 0, right? So by knowing this, we have to respond the next question. So the slope is this number here, the number multiplying the x. You know this from your course from pre-calc. This is the slope, 0.03, 023, I'm sorry. So the slope is 0.023, means that on average the BAC decreases by 0.03, no, increases, because the slope is positive. If the slope is positive, the relationship between the two variables is, as one is increasing, the other one is also increasing. So we have to look for the option, this one. The slope is 0.023. This means that on average the BAC increases by 0.023 for each drink consumed. Why do you think the intercept is 0? Well, I don't know what can be a right interpretation here, but I think it's this one. The intercept is 0 because individuals who did not have any drinks had that BAC of 0. Part B, for a woman weighing 120 pounds, BAC increases by 0.038 on average for each drink taken in 1 hour. What is the equation of the regression line for predicting BAC for number of drinks for a 120-pound woman? In this case, it's going to be the same model as this one we have here, but instead of using 0.023, we have to use this number. So it's going to be the model in this case. It's going to be y hat equal to 0.038x, but y is the BAC and the x is the number of drinks, so only look for the right option, and I think is this one. It says, find the predicted BAC for 160-pound male who consumed 4 drinks over the last hour, and for a 120-pound woman having 2 drinks in 1 hour. Oh, in this case, we have to use the two models. For males, it is only wait a second, 0.023 times 4 for 160. I think we have to use the two models, 160 pound for drinks. So in this one, you have to only multiply the model for men is BAC or Y hat equal to 0.023 times X or drinks. So only replace the X by 4. You're going to get 0.023 times 4, 0.092. Wait a second. So will be 0.023 times 4 for male, and the one for women is 0.038 times X, which implies Y hat equal to 0.023 times 4 here, and here Y hat equal to 0.038 times 2. 0.023 times 4, 0.092. And here for women, 0.038 times 2, 0.076. I don't know why I thought I got different answers before, but well, I think that is correct. If not, I will let you know. And finally, should the best explanation of why these values may not be the individual's actual blood alcohol contents. And here, well, we have several options, right, to choose. The correct one. Other factors contribute. Well, we have we have the same in every sentence except in the first one. And I think the right one is this one. Other factors contribute to the variation in BAC other than gender and weight. For example, the individual's metabolism and food consumption prior to drinking would contribute to the variation, right? We're done with this problem. And this one is the last one. That one example from a sheep. You have to take into account something that I have to mention about correlation. It says, identify the reason the following statements are incorrect. Not the reason will be used. So you're going to have several options to choose from, but I'm going to let you know why this is wrong. First, researchers found that the correlation between the number of hours students study for a test and their test score is R.56 hours. This is wrong. Correlation, why? Correlation does not depend on units. I mean, This one is wrong. The correlation coefficient is a standard measure. It doesn't have any units. So we cannot report a correlation with units like in this example we have hours. Next example, the correlation between scores on an intelligence test and the test taker's hair colors. This is wrong. We don't use categorical variables here. Both variables should be numerical. And then diastolic blood pressure and systolic blood pressure are highly correlated. What is wrong here? I mentioned before the correlation coefficient always must be between 1 and -1. So it's impossible that we can have 1.05. Something must be wrong with the computation for this correlation. So this is not possible. And finally, the correlation between average gas mileage in miles per gallon and average highway speeds in miles per hour differs from the correlation between average gas mileage in miles per gallon and average highway speeds in kilometers per hour. So what it is, again, correlation the correlation is given by using units. Correlation between average gas mileage in miles. Mileage in miles. This is impossible. Again, correlation doesn't have units. And that's all. I think you can do the other exercises on the homework from a sheet. Anyway, if you have any question, send me an email or use the schedule office hours or talk to me so we can arrange an appointment for virtual office hours. See you.